This conference will now be recorded.
Just a minute, Python is loading.
This conference will now be recorded.
Our file was this one. Where is our file? The comments. Yeah, this is our file. So within this file, there are two things. Comma is the separator. Left side of the comma, input text. That is what feature. But feature in the form of text feature. We should extract numerical features from that. And right side of the comma, there are labels. But input features and labels both are in text only. So we need to do two things. We need to separate them. Input should be as a matrix, that too as a feature matrix, numerical features. And labels, character labels, we should convert into binary labels. That means numerical labels. You can treat positive as 1, negative as 0. Like that you need to transform. So first of all, the related code I am writing. The file path. F dot read lines is a statement. Let's say the data is lines. Now what is the object type of line, sir? List. List has a number of elements, wherein is number of lines in the file. Suppose there are 100 lines, 100 elements. Each line has an element. This is the content. If you observe this, for each line in the last, \n was recorded. Okay, that is because of enter key. So we need to remove that one also. So first I'm going to separate one lines, let's say lines L or text, one empty list first. For numerical labels, let's say label. This is also one empty list. Performing a loop for line in lines. First I'm splitting each line. Always better practice. First convert all the things into one neutral case, either lowercase or uppercase, and then remove white spaces, both left and right sides. This is strip function not only removing that white spaces, invisible characters also, like backslash t tab space, backslash and enter key, such kind of invisible characters. For that I am splitting delimiter comma. How many commas you have? Two commas. That's why two fields you will get. First the text line. Let's say T. W of 0. First one is text line. That means input text. Label. Default value I am keeping 1. If W of 1, that means second character, second field, is equals to negative, then you are making it as let's say L is equal to 0. Suppose if it is not negative, L value already 1. If it is negative, you are making L value as 0. Now I am appending text dot append of T. Label dot append of L. After completion of this loop, what will happen? Just observe. Print text. Only text part will be here. Within that, there are no labels. Next, print label. Previously, labels were character labels. Now you will see numerical labels. There are 2 positive, 3 negatives. Now, basically, 2 techniques. Of course, a lot of techniques. Among them, word frequency feature, that is one feature. TF-IDF is another feature. Word frequency, for word frequency, here in Python, you have that too in SQL library. You have a predefined class called count vectorizer. So first with the count vectorizer, I will extract the features. We need to import that class from scalar dot feature underscore extraction dot text. It's the package. From this you are importing count vectorizer. Okay, just run and check it. So that means that package is correct. The way of processing is first you need to create a vectorizer object. VEC equal to count vectorizer of object is created. After that you have to feed the text into that one. VEC dot fit. That means you are loading text into that particular object. What is your object? Text. It should be a list of all the given text lines. After that, you are extracting numerical features. VEC dot transform of text. Now we want to know the vocabulary. That means what are the words, what is the column position of that word in the feature matrix. For that, print VEC, that vectorizer object, dot vocabulary underscore. Totally observe the counts are here. 0, 1, 2, 3, 4, 5. That means 6 unique words appeared here from the given text. Among them, the first column is 0, sir. For the 0 value, what is the word appeared? Admire. For 1, hate. For love, 3. That means the column index 3 means fourth column. In our matrix, the fourth column is about love. The first column is about admire. Like that. Okay. So what is that feature matrix? The feature matrix is in V. Print V. How many rows you have, sir? In the given text, how many rows you have? 5 rows. That means how many things you will get? What is the size of this V? 5 by 6. 0 to 5 means 6, right? So 5 rows, 6 columns. That will be your input matrix. Just check it now. This is the shape. Total observe for 0, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Something still output is available in the below. This is just a feature, but we need it as matrix. That's why 2 array. Here I am applying dot 2 array. Now check the same thing here. Understand? 5 rows, 6 columns. Now this is one input matrix. So every time instead of repeating this, you can make it as a function. Come on, tell me the function. Already know the statements. Define count feature. Let's say X is your text list of text. First, better in the function, import that class from scalar dot feature underscore extraction dot text. Import count vectorizer. Then create your objects. VEC count vectorizer of. Then load the text into this one. Dot fit of text. Then extract numerical features. V equals to VEC dot transform of that text. Convert that into array, double dimension array to array. Finally return that V. Okay. Now check the functionality. Count feature of my given text. Understand? Automatically numpy array will get it. This is one numpy array. Same style. What is that feature, sir? TF-IDF. I want to use TF-IDF. What is the change in this? You tell me the change. Just replace the class name, that's it. The class name, TF-IDF, vectorizer. Just create object for TF-IDF vectorizer, remaining as usual. Okay. Now check the thing. Print. Sorry, first call it. Let's change the name of this function. TF-IDF feature. I'm calling that TF-IDF of. Sorry, TF-IDF. Just to give the short name for this function. The function name is TF-IDF. TF-IDF of. What is your text? This. We did not run the previous one after changing the name. Now run it. These are the TF-IDF values. So why it is better feature already we discussed. Okay, when compared with other different models. So what are the other models? Existence feature, frequency feature, proportion feature, lexical and lexical diversification, finally TF-IDF. These are the features. This is what our last session. Okay. 1 minute.